Good morning, students. How are you? Myself, Rashmi Yande, your science teacher. Today, we will continue our third lesson, force and pressure. In last lecture, in that video, we discussed certain points from this lesson, that is the definition of force, types of the force, contact force and non-contact force, difference in between that. Next point, it was certain examples of contact and non-contact force. Second type, it is balanced and unbalanced force, characteristics of that and examples. Today we are going to start the next point of this lesson, that is the inertia. First of all, we will understand the definition of inertia, the tendency of an object to remain in its existing state. It is called as the inertia. Any object, they have a particular state and they remain in its existing state. That concept, it is nothing but the inertia. And due to the inertia, an object in stationary state remains in the same state, and an object in motion remain in the state of motion in absence of external force. So whatever, both situations are there in inertia. If that object is remain constant or stationary, then it remains stationary. That is due to the inertia. And if any certain object, it is in motion, it remain in the state of motion although there is an absence of an external force. This continuously motion, it occurs due to the inertia. Here activity is there. Take a postcard and keep it on a glass. Keep a 5 rupee coin on it. Now skillfully push the card. The coin straight away falls in the glass. This activity is related to the inertia, because inertia have mainly two types: inertia of the state of rest and inertia of the state of motion. Second activity is also there. Hang a half a kilogram mass to a stand with a string. Tie another string to mass and keep it hanging. Now pull the string second with a jerk. The string second breaks, but mass does not fall. Heavy mass does not move. The string first breaks and the mass falls down. This is because of the tension developed in the string second due to the mass. So in the types of inertia, there are three types of inertia: inertia of the state of rest, inertia of the motion and directional inertia. First type, it is the inertia of the state of rest. An object in the state of rest, that means in constant position, no movement is there, cannot change its state of rest due to its inherent property. This property, it is called as the inertia of the state of rest. कोई भी object ले लो आप, suppose this is a object, a block is there. Okay, until I move this block from one place to another with the help of force or by applying the force, that object will not move. That means that object will not change its state of rest. Second type, it is the inertia of motion. The inherent property of an object due to which its state of motion cannot change, it is called as the inertia of motion. For example, a revolving electric fan continues to revolve even after it is switched off. Passengers sitting in the running bus get a jerk in a forward direction if the bus suddenly stops. Third one, it is the directional inertia. The inherent property of an object due to which the object cannot change the direction of its motion. It is called as the directional inertia. For example, we can say if a vehicle in a motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of turning. These two are the opposite direction because that object cannot change its direction of motion. So these are the three types of the inertia. Next point, it is the pressure. What is the concept of pressure? And with certain examples we will discuss the pressure. You must have observed the tires of two-wheelers and four-wheelers getting pressurized. The air filling machine has a pressure indicating dial or a digital meter showing the digital reading of pressure. The machine fills the pressure to a certain value. You are aware that a force has to be applied for filling air in the bicycle tire with the hand pump. By applying force, air pressure is increased and then the air is pushed into the tire. Are force and pressure are related? Yes. If we increase the force, if we increase the applied force, that means the pressure is also increased. That means force and pressure, they are directly proportional to each other, we can say. One activity is there for better understanding. Take some sharp pointed nails and push them into wooden plank by hammering on their heads. Now take a nail and hold it with its head on the plank and hammer it down from the pointed end. When pressuring the drawing pins into a drawing board, they get into a board easily. By applying a force using the thumb, one can push the pins into the board. On the contrary, while pressing ordinary pins into the board with the thumb may get hurt. From this you will notice that when a force is applied on the head of the nail, it is easy to hammer it into the plank. The force exerted perpendicularly on a unit area, it is called as the pressure. Therefore, the formula of pressure, it is pressure is equal to force upon area on which the force is applied. The SI unit of force is Newton. We know that force is always measured into that is the unit of force, it is the Newton. Area is measured into meter square. Therefore, SI unit of pressure is Newton per meter square. It is known as a Pascal, that is the PA. In atmospheric science, the unit of pressure is bar, that is the 1 bar is equal to 10 raised to 5 Pascal. So this is for your knowledge, but you have to understand the unit of pressure, Newton per meter square, and pressure, it is a scalar quantity. Here, due to natural adaptation, the bottom surface of camel's feet are broad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. That's why camel's feet do not penetrate into the sand and it becomes easy to walk, because we know that camel is commonly used for traveling in desert area. What is the reason? Because that feet of that camels, they are broad at the bottom side. Therefore, area is more, so pressure it get reduced. Next point, it is the pressure on solids. Now here we understand we discuss the concept of pressure. Now pressure on solid, pressure on liquid and pressure on gas, because we know that each and every matter have three states: solid, liquid and gas. So what is effect on these three states, we will discuss it.